Hey everyone, today we're going over Dungeon Game. So the way this game works is I'm going to start in the upper left hand corner. I can move either right or down, and my goal is to get to this corner where the princess is. And these numbers are basically telling me as soon as I enter this room, this is the amount of health that I'm going to gain or lose. So if it's a negative number, well, I'll lose 2 health. And then if it's a positive number like this one, then I will gain 1 health. And the question's asking, what is the minimum amount of health that I need to start with such that I can make it successfully to this corner where the princess is? And basically I will die as soon as my health is less than 1. So as an example, let's say we're entering this square here. If I have 0 health, well, I'll basically die immediately because my health will be less than 1. However, if I have 3 health, I can enter this room successfully because I will have health 1 remaining after I enter this room. So let's take a look at how the initial example provided works. If we have a health of 7 initially, so we enter this room, we're left at 5 health, then 5 minus 3, now we have 2 health, then we enter this room, we have 5 health, enter this room, then we have 6 health, enter this room, and we have 1 health, and that means that we have successfully reached the princess and we win the game. Now let's say the health had been 6, well, then we would have 4 health upon entering this room, then 1 health, then 4 health, then 5 health, but once I enter this room, I will have 0 health, which means that I will die and lose the game. Hopefully the structure of this maze or this dungeon here reminds you of using a DP solution. So the equation that we're trying to solve is at each room, what is the minimum amount of health that I need to enter the room? And then the second part of the equation is, well, there are 2 ways to enter each room, and which path should I take? Take a look at how to fill in our DP grid here. So if we look at our destination, that's saying we will lose 5 points of health as soon as we enter this room, right? And the only way that I can survive entering this room is if I have health greater than or equal to 6, right? If I have 5 units of health, if I enter this room, then I'll have 0 units, but the problem states that we need at least 1 unit of health to survive entering a room. So I will go ahead and fill this in as 6. Bottom row. If I want to enter this room, I'm going to gain 30 points of health. And that's way more than this -5 I'm going to lose, right? Just remember that the problem said the minimum amount of health that I need to enter a room is 1 unit. So the minimum value that we'll ever put in this DP array is going to be 1. Similarly here, I'm going to gain 10 units of health, won't need that much, and I can just put a 1 here. All we're going to look at are along this right wall here. And these ones are a little bit easier to think through because there's only one way to get to this cell, which is the cell above it, right? So this room is saying as soon as I enter, I'm going to gain 1 unit of health. And if we look below it, this is saying that I need 6 units to be able to enter successfully, right? So if I had 5 units initially, and then I gain this 1 unit of health, then on my next turn, I'm able to enter this room successfully. That's why this value is a 5. And if this value is saying that I'm going to gain 3 units of health, and I know that I need 5 units to be able to successfully reach the princess from this cell, then I just need 2 units of health, right? So let's walk through this. If I have 2 units here, then I'll gain 3, and then I'll have 5, enter this room. 5, then I'll gain 1, then I have 6 units, and then I'm able to successfully enter this room, because 6 units minus 5 is still greater than 0 here as well. Now let's fill in this middle square here. So we're going to lose 10 points of health as soon as we enter, right? But we know that the next 2 options on where to go, well, one of them only requires 1 unit of health, and one of them requires 5 units of health. So I'm going to want to go to the one that requires less, right? So if we think about what this value needs to be, well, if I have 11 units of health and then I lose 10, I'll be able to survive entering this room. and then I can successfully make it onto the next room, which only requires 1 unit of health. Similarly, for this cell, I'm going to lose 5 units of health as soon as I enter, so I'll need at least 6 health, right? And once I have 6 health, I lose 5, I'll be left with 1 unit of health. But luckily, I only need 1 unit of health to enter this room. So that's why this value is going to be a 6. Now when I look at this cell, I see that the next path that I want to go to is going to be this cell because it only requires 2 units of health. So if I start with 5 units of health, then once I lose my 3 units, I will have 2 units of health and I can successfully make it to this room here. And finally, this cell, I'm going to lose 2 units of health initially, and the next cell that requires a lesser amount of energy is going to be this one, and it requires 5 units of health. So that's why I need to start with 7 units of health here. So we see that the minimum amount of health required is going to be 7, and the path we're going to take is 7, 5, 2, 5, 6. So here I've typed out the process that we just ran on this DP matrix to fill it in. Notice that each of these statements always take the max of 1 and some other expression. And this is because if you think about the problem statement, it says that we always need minimum health 1 to enter a cell. That is really important to understanding this question. And the reason that this value could ever be negative is in a case where the cell has positive health. And we wouldn't want to say, oh, well, I only need negative 29 health to enter this room because I'm going to gain 30, right? Because your health always needs to be positive. So when we looked at the bottom row, we only had to look at the number directly to the right of the current cell. So it's represented as ij plus 1. And for the right column, we only needed to look at the number that was right below us, and that is dp of I plus 1j. And for the rest of the grid, well, there was a decision that we had to make here. Which of the 2 cells to the bottom or to the right has a lesser cost, which is the min here, and then we subtract off the cost here. So as an example, let's say we're on this cell, this negative 10. Well, what is the minimum between 5 and 1? It's going to be 1, right? And then 1 minus negative 10 gives me 11. So what is a max of 1 and 11? That is 11. We'll use these equations to fill in the grid from bottom right to top left. And the question is asking what is the initial health that we need? Well, that's represented by this value at dp of 0, 0. So here's how the code looks. One thing that I'm doing to save a little bit of space is instead of dedicating a separate DP matrix, I'm just reusing the original dungeon matrix that was provided to us. So what we're doing is we're starting from the bottom right corner as indicated by this iteration pattern. And this statement is just saying, okay, if we're at the bottom right corner, we'll initialize it to the value that we decided on earlier. Now this is saying, well, if we're on the bottom row, we just need to check the cell to the right of us. If we're on the right column, I just need to check the cell directly below me. Otherwise, I make the decision, is the bottom or the right cell the one with the lower cost? And then I subtract the cost of the current cell that I'm on, and I take the max with 1. And finally, I return the initial cost, which is at 0, 0. And if I submit the code, we see that it is accepted. Thanks for watching.